Unit 6, Lesson 2, Slope Formula. So today I'm going to teach you how to calculate the slope of any given line using a formula. So in the last day, I taught you how to calculate the slope using the rate triangle method. Today I'm going to show you how to calculate the slope algebraically using a formula. And this is actually the way you're going to do it for the rest of grade 9 and into grade 10. So this is the method you want to be very comfortable with. But it's an extension off of the rate triangle method. So we're going to get right into an example. So using the rate triangle method from yesterday, figure out the slope between the 2 points listed. Okay? So yesterday's rate triangle method tells us to first plot the points. So 7 and 6 and 3 and 2, then connect the dots. Okay, now we draw a triangle below the line using the 2 points. So there's my rate triangle. Okay, the rise is this side because the vertical change, and this side of the triangle is the run because it's the horizontal change. So the rise starts at 2 and it rises up until 6. So the difference between 6 and 2 is 4, so the rise is 4. And we keep the rise positive because this slope is a positive trend or a positive slope because it's going up and to the right. And then the run starts at 3 and goes until 7. So the run is 4 as well. Now we take those values and we plug it into the slope formula. And then we simplify. So this can be reduced to 1. So the slope of this line using the rate triangle method is 1. Now, here's what I want you to notice, and this kind of leads us into learning the new method. So I want you to notice that our rise was 4, right? You know that. But look at this. So if you look at the actual points, okay, the coordinates. This is the x value of that coordinate, this is the y value, right? 7 is the x, 6 is the y. So if you actually subtract the two y values, so 6 minus 2, you get the same number, a rise of 4. Likewise, using the rate triangle method, we figured out that the run was 4. But just look at the points. If you subtract the x values, so 7 minus 3, you also get that run of 4. Okay, so there's actually a quicker way to calculate slope. Instead of drawing out the entire graph, then drawing your rate triangle, we could have actually calculated the slope just by looking at the original points. So I'll show you how to do that now. So before, you guys knew that the slope formula was rise over run. So that was a really good and convenient formula when using the rate triangle method. And we realized that the rise is just the difference in the y values and the run is just the difference in the x values. So the mathematical symbol to represent the word difference is this triangle. Okay, so all this means is the difference in the y values divided by the difference in the x values. So we can further write this equation for calculating slope like this. y2 minus y1 divided by x2 minus x1. And this is the same as the slope formula from yesterday. It's just extended a little bit more and a little bit more specific. So moving forward, I want you to use this formula for calculating slope because it's going to be very relevant to calculating slope just from 2 points. Okay, and then you can totally skip the whole graphing step. So let's go back to our original example and I'll show you how to use this new formula. So let's say you were given example 1 again. I'm now going to show you how you could have solved it using the algebraic method. And I'm going to do it right beside the rate triangle method. And you're going to see it's so much better. It's shorter. Okay, so question 1. Determine the slope between the points 7 and 6 and 3 and 2. So So using the algebraic method, the first thing you would want to do is write down the new slope formulas. So slope equals y2 minus y1 divided by x2 minus x1. Okay, so that's step one. Write out your formula. Step two is label your points. So every point is made up of an x value and a y value, right? The x number is first, the y number is second. So I want you to label these 2 points. Pick your first point and label it as x1 and y1, and then take the second point and label it x2, y2. So this is my first point in the list. So this is the x value in the first point, and this is the y value in the first point. So that's why it's x1 and y1. This is the x value in the second point and the y value in the second point. And again, that's why it's x2 and y2. Okay, step 3 is now plug those values into the equation. So y2 is actually, I labeled this guy as y2, it's actually 2, minus, what's y1? It's 6, divided by, what's x2? Okay, it's 3, x2 is 3, minus, what's x1? It's this guy, 7. Now we just do the math. So 2 minus 6 is negative 4, 3 minus 7 is negative 4, and negative 4 divided by negative 4 is 1. So look at that. We got the same answer as we did using the right triangle method. And this was much shorter. We only did that much work. For the right triangle method, you did some calculations and you had to do an entire graph. Okay, example 2. Determine the slope between these 2 points using your right triangle method and then your slope formula method. So let's first do the old method, so the right triangle method. So negative 4 and 2, plot the points, and then 2 and negative 2. Okay, connect the dots, draw on your right triangle. Okay. Then we know using our right triangle method, the formula for slope is rise over run. So the rise starts at 2 and goes down to negative 2. So the difference is 4. And because this is a negative slope, right, it's a negative trend, we know we have to add in a negative sign for the rise because it's actually going down. So rise is negative 4, and then the run starts at negative 4 and goes until 2. So the difference is 6. So then the slope is negative 2 over 3 after reducing. Okay, let's use the algebraic method. So first write down your slope formula. So it's y2 minus y1 divided by x2 minus x1. Second is label your points. So let's pick this one to be our first point. So he's going to be x1 and y1. And this guy's going to be our second point. So x2, y2. It actually doesn't matter which one's your first or your second point. I could have picked this one as my first point and labeled it x1, y1. And this one as my second point and labeled it x2, y2, and I would have got the same answer. Okay, now let's plug in our values. So y2 is negative 2 minus y1, which is 2, and then divided by x2, which is 2, and x1, which is negative 4. Okay, now let's simplify. And let's reduce. And look at that, we get the same slope in a much quicker way. Okay, let's finish this with one last question. So, example 3, determine the slope between the 2 points using the slope formula. So, the slope formula is y2 minus y1 over x2 minus x1. Step 1, write down your formula. Step 2, label your points. So x1, y1, x2, y2. That is so important that you label them. Some of you might think, oh, I'll just remember which one's x1 and y1. I see so many people make mistakes because they forget to label them. So please, please, please always label your points. Okay, step 3, let's plug in our values. So y2 is 8, y1 is -4, x2 is 5, x1 is -3. Now let's do the math. So remember, two subtraction signs beside each other are actually an addition sign. So we get 12 over 8. We can divide those each by 4. So we get 3 over 2. So just remember, when you're given 2 points and asked to calculate the slope, use that slope formula method. And then remember to always label your points x1, y1, x2, y2 first. And then remember to label your points as x1, y1, and x2, y2 first. Then plug them into your formula. Slope equals y2 minus y1 divided by x2 minus x1.